Suppose that f of x is continuous, the closed interval a comma b, and f of x is differentiable on the open interval a comma b. If f of a equal to f of b, then we can say that from the Rolle's theorem, so there exists at least one x, okay, in the open interval a comma b, such that so f dash of x is equal to 0. So verify Rolle's theorem for f of x equal to x power 2m minus 1 a minus x. So sine of x by e power x. So in the interval 0 comma pi. See, in order to verify the Rolle's theorem, I need to check these three conditions, right? Whether f is continuous on the closed interval and it is differentiable, and f of a equal to f of b. So then only I can say I can verify the Rolle's theorem. If any one of these three conditions fails, I can say that the Rolle's theorem is not applicable for this function. Is that clear? So here also we have a function, sine function. What can you say about the sine function? It is continuous as well differentiable, is it not? So here I know that x by e power x is there. So e power x is not equal to 0 for any x. So that is one advantage here. This is defined. Okay, if you give 0 also, e power 0 is 1. It is not 0. So I can say that the function is defined for every real number in the interval 0 comma pi. And here what is your a? A equal to 0, and what is your b? B equals to pi. Right? So say being a trigonometric function, I can say that sine of x by e power x is continuous as well differentiable. F of 0 is 0. What is your f of pi? What is that? It is 0.1353, is it not? So can you say that f of a equal to f of b here? So what happens here? F of 0 is what? It's not equal to f of pi, is it not? Therefore, what is your conclusion? The Rolle's theorem is not applicable for this. Verify Rolle's theorem for the function f of x equal to, so log of x square plus ab divided by a plus b into x. So I want to verify the Rolle's theorem for this. So I need to check these three conditions first. Whether the given function is continuous, differentiable, and f of a equal to f of b. Then only I can apply the Rolle's theorem. Yeah. So what can you say about this function? Log function. What can you say about that? At what point it is not continuous? We all know that log 0 is what? Is minus infinity, right? So it is not defined at 0. And for the negative real numbers also it is not defined. It is defined only for the positive real numbers. Okay? Yeah. So here I can say that a and b are what? So here a must be not equal to 0. That is one condition. Okay, if a equal to 0, I cannot say that the log function is okay. What happens if a equal to 0? We have x square by b into x. B is non-zero here, right? If I substitute a equal to 0, what happens? We have x square by b into x. Is it not? If I substitute a equal to 0. So I can cancel this x so that we have what? X by b. So if x equal to 0, what happens? Log 0 is minus infinity. That is not defined. So a must be not equal to 0 here. Right? Yeah. Now here a is not equal to 0. Then condition add multiple. Fine. Now I want to check whether this is continuous. Yes, it is continuous. So on the positive here, a and b both are positive. Now clearly I can say that the log function is continuous on this interval, and it is differentiable also. What is the differentiation of log function? It is 1 by function. The derivative exists, right? So it is differentiable also. So write down. So clearly, so f of x equal to, so log of x square plus a into b divided by a plus b into x, continuous on the closed interval a comma b, and differentiable on the open interval a comma b, where what can you say about a and b here? So a is greater than or equal to 0? No, it is strictly greater than 0. If A is greater than 0, automatically B is also greater than 0. Why? We are talking about the closed interval A comma B, right? If A is more than 0, B is further more than A, right? So B is also more than 0. That is understood. I want to check what is the f of A and f of B, because A and B are the endpoints here. What is f of A? Substitute x equal to A here. What happens? So A square plus AB divided by A plus B into A. I just substituted x equal to A. Now let me simplify this. It is log of, I can take A common here, right? So it is A plus B. In the denominator also I am having the same thing. A plus B. What happens here? It is log 1, right?
Yes, sir.
So what is that? It is defined 0. Log 1 is 0. Now let us check f of B. So let us substitute x equal to B now. So B square plus AB divided by A plus B into B. So that is equal to, so log of, if I take B common here, so B plus A, in the denominator we already have what? The same thing, right? A plus B equal to B plus A. So again, it is log 1, so it is 0. So I can say that f of A equal to f of B here. Okay. So the given function is continuous and it is differentiable, and f of A equal to f of B. So what is the Rolle's theorem says? There exists at least one C. Let me take x. C beta. Let me take x only. One x in the open interval A comma B, such that f dash of x equal to 0. Very. Let's calculate f dash of x now. What is f of x? Tell me. It is log of x square plus AB divided by A plus B into x. So let me calculate the differentiation now. So tell me, what is f dash of x? What is the differentiation of log function?
1 by
So 1 by function. So 1 by function. What is that function? So x square plus AB divided by A plus B into x. If you take a reciprocal for that, what will you get? The numerator will become denominator and denominator will become numerator. So it is A plus B into x divided by x square plus AB. This is, first we have to differentiate the whole function. I differentiated the log function. This is what I get. Now I want to differentiate the function. What is the function here? Square plus AB divided by A plus B into x. This is the function. Now, so this is equal to, so A plus B into x divided by x square plus AB. Right? Now I want to differentiate this. How can you do the differentiation for this? You have to apply the quotient rule, right? So what is the quotient rule says? What is the differentiation of numerator by denominator? Tell me.
Denominator square.
Denominator
Numerator differentiate.
into differentiate the numerator minus numerator differentiate the denominator divided by denominator whole square. So here, what is the denominator? So A plus B into x. Now I want to differentiate the numerator. What is the differentiation of numerator? Tell me. We have x square plus A into B. What is the differentiation of x square?
2x.
It is 2x. Always remember, the differentiation of x power n is what? It is n into x power n minus 1. Right? So as a consequence, the differentiation of x square is 2x. Plus, what is the differentiation of A into B?
0.
It is 0. A and B both are constant. And differentiation of constant is what? It is 0. Okay. Denominator, derivative of numerator minus numerator. What is the numerator? This is the numerator. And now I want to differentiate the denominator. What is the denominator here? We have A plus B into x. What is the differentiation of that? So if I have only constant, the differentiation of constant is 0.
Yeah, but A plus B.
Here I have constant as well variable. At this situation, you have to take the constant term outside and you have to differentiate the variable. So you have A plus B into x as the denominator, right? So A plus B is constant. Take that outside. Now differentiate x with respect to itself. It is 1, right? Denominator whole square, which is A plus B into x whole square, right? I can cancel one term here, right? a plus b into x and 1 a plus b into x. I can cancel that. So what is the remaining thing here? It is 1 by, so x square plus ab. So we have a plus b into x here. Here we have a plus b. So I will write a plus b as it is, and I will multiply this x here. What happens? It is 2x square, x into 2x square, minus x square plus ab, and I will write this a plus b as it is, divided by, what is the remaining thing here? 1 a plus b into x is cancelled, right? Remaining is 1. So this is equal to, which is 1 divided by, so x square plus ab into a plus b into x, right? Now what happens to the numerator? I can take a plus b outside, right? I can take a plus b common. What is the remaining thing here? I can take a plus b common here. So what is the remaining thing? So 2x square minus x square. So I can cancel this a plus b also. So what happens here? So we have, which is 2x square minus x square is x square minus ab divided by x square plus ab into x. Now we have to equate this to 0. F dash of x is 0, right? According to Rolle's theorem, it is 0. What is f dash of x? It is x square minus ab divided by x into x square plus ab. What is that? That is equal to 0. See, if you equate to 0, what happens here? The denominator will shift to the right hand side, and in the right hand side we have 0. 0 into that is again 0, right? So what will you get? So x square minus ab equal to, so what is x square here? What can you say about x?
Root of a.
It is plus or minus root a into b. We have two values here. One is root a into root b, and another one is minus root a into root b. So here we must have root a into root b. Why? Because according to Rolle's theorem, there exists at least one. It is sufficient to have at least one x which satisfies f dash of x equal to 0, and x is in what? The open interval a comma b. So here, so we can say that among these two roots, I can say that x equal to root a into b is positive, and hence I can say that is that belongs to the open interval. Let me take 2 comma 3, the interval. See, if you consider root 2 into root 3, what happens? Take the calculator and tell me. Is that belongs to the open interval 2 comma 3? Tell me. So in the same manner, in general, I can say that root a into root b is belongs to the open interval a comma b. Hence, so Rolle's theorem verified.